Hello, I'm Dr. Ziata here. This video tutorial is solution to problem 4 by 27 from Engineering Mechanics Statics 9th edition. Statement of the problem is determine the force in member CG. So a force in a single member is required in CG. So the best method to analyze this truss is method of section. So finding member force using method of section. So these are the steps. The first one is need to plan a cut and then choose an imaginary cut that passes through the target member. So that there is a target member. So need to cut it through G, F, G, C and B, C along here. So that's a cut, and that cut is going to split whole truss into two sections, the right section and then a left section. And then you need to choose a simpler side of the cut with fewer loads reaction and fewer joints. So on the left cut, so there is a support and then there is another support. So need to find support reactions. So left cut I'm not going to select because it has three unknown reactions. So I'm going to select right side of the cut and then need to draw its free body diagram by showing all external loads, reaction on this side, and represent the unknown cut member forces assuming tension. So on the cut, there are three member forces, unknown member forces, FG, CG, and then BC. So they are being represented here, FG, CG, and BC, all three. I have assumed them in tension. And then two known forces at point C and D, 5 kilopounds each. So that is being represented there. Next step is to apply equilibrium to the cut part to find unknown and use sigma m equal to 0, then sigma fx equal to 0 and sigma fy equal to 0 to find unknowns. So there is one inclined member CG making an angle 45 degrees because all sides are so in a triangle both sides are same. So if two sides are same and if the triangle is right angle, so then both angles other than right angle are 45 degrees. So simply that CG makes an angle 45 degree with the horizontal. So CG can be resolved into two components, one going towards left, towards negative x-axis, that is CGX, and one of the component is CGY, which is acting vertically upward. So in this problem, CG is only required. So the only member force required is CG. So then we will see that which one rule we will apply, sigma fx, sigma fy, or sigma moment about 0. So here CG is the only unknown in vertical direction. So only unknown in vertical direction is CG. So it's the best that we will use sigma Fy equal to 0. And for sigma Fy equal to 0, CG is taken as positive because it is towards positive y-axis. And then both have loads of each of 5 kilonewton. They are acting vertically downward to a negative y-axis. So they are taken as negative. So sigma Fy equal to 0 is can be written as plus CGY upward minus 5 both are acting downward is equal to 0. So CGY is CG sine 45 and then minus 5 is minus 10. On the other side it will become plus 10. So then CG is equal to 10 over sine 45 which comes as 10 root 2 or it is 14.142 kips. So once member forces are calculated, so then the interpretation of the sign of unknown member force. A positive value indicate tension. So that answer is positive. So the positive value indicate tension. So then the answer will be as CG as 14.142 kips in tension. So that is the answer. So The answer at the back of the book is CG 14.14 gives intention. So that is the solution to this problem. Thank you very much for watching.